All right, welcome to The Explainer. Today we're tackling a really fundamental question in AI. How do you find the absolute best solution to a problem without, getting totally lost on the way there? So let's just dive right in with an analogy that the researchers themselves use, learning how to walk. Think about it. If you want to get faster, what's the better strategy? Do you try out every single possible way to move, limping, hopping, shuffling around? Or do you find a pretty decent way to walk and then just pour all your energy into making that perfect?
Well, that choice right there, it perfectly sums up this huge dilemma in AI optimization. It's this constant tug of war between finding the one single best answer, what researchers call quality, and on the other hand, finding a whole bunch of different good solutions, which they call diversity.
And this brings us to the million-dollar question, right? The one researchers have been wrestling with forever. How do you find that one perfect solution without getting stuck in a dead end? And how do you do it without wasting a ton of time checking out options that, well, they're just never going to be the winner? Okay, so to try and solve this, two main schools of thought kind of popped up. And it's really helpful to think of them as two totally different personalities. You've got the perfectionist, who is all about quality, and then you've got the explorer, who is, you guessed it, all about diversity. This slide just lays out the trade-off so clearly. So, on one side, you've got the perfectionist. Think of this as evolution strategies. Its goal is simple: find the single highest score. It's laser-focused, but the big downside? It can get some serious tunnel vision, totally missing a better path that's right next door. Then, on the other side, you have the explorer. This is your quality diversity methods. Its whole deal is to find a huge variety of solutions. It's fantastic at exploring and not getting trapped, but it ends up wasting a lot of time on options that honestly are never going to be the best.
And this is where our new approach comes into the picture. It's got a great name, JEDi, which stands for Quality with Just Enough Diversity. And really, it's designed to give us the best of both worlds.
The real aha moment, the big idea behind JEDi, is actually super simple but so powerful. It's this: what if the explorer could just tell the perfectionist where to look? So instead of exploring all over the place with no real goal, JEDi explores just enough to create a map of the most promising areas. And then it sends in the perfectionist to find the absolute best solution, but only inside those specific zones. So how does this actually work? Well, it's basically a four-step loop. First, JEDi builds what you can think of as a performance map. It's learning which behaviors lead to good scores. Then, step 2, it looks at that map and picks out the most promising targets. Step 3 is the cool part. It sends in a perfectionist, one of those evolution strategy specialists, to really dig in and find the best possible solution right around that target. And finally, it takes what it learned, updates the map, and just repeats the whole process, getting smarter and smarter each time. Okay, so the theory sounds great, right? But does this clever hybrid approach actually work any better when you put it to the test? Let's get to the results and see what happens in a real showdown. So to really put this to the test, the researchers used a few different complex tasks. We're going to focus on a classic one: teaching a virtual robot, the Walker 2D, how to walk as fast as it possibly can. And believe me, this is a really tough problem because it's super easy for an algorithm to get stuck in a walking style that's just kind of okay, but not great. All right, first up, let's look at the pure explorer method, map elites. These images here tell the whole story. On the left, you see the quality of solutions it found. A few bright spots, yeah, but they're scattered all over the place. Now look at the map on the right. That shows where it spends its energy. And the answer is everywhere. It's exploring the entire landscape, but because its effort is spread so thin, it only manages to find a pretty mediocre solution, with a score of 2118. Okay, now for the perfectionist, the evolution strategy. Whoa, big difference. It finds a way better solution, hitting a score of almost 4,000. That's that super bright yellow spot on the left. But look at the map on the right showing its effort. It focused all of its energy on one tiny spot. This is that tunnel vision we were talking about in the flesh. It found a good hill to climb, but it was totally blind to everything else around it. And now, JEDi. This is where it all comes together. The map on the left shows it found this clear, super high-performing path, way better than the other two. And the effort map on the right shows us exactly how it pulled it off. See that? It didn't waste time searching everywhere. It just focused its search intelligently right along that promising path.
And by combining that smart exploration with focused perfection, it just blows the others away with a score of over 5,500. This graph pretty much tells the exact same story, just over time. We're looking at the best score found as these algorithms keep running. And that red line, that's JEDi. It just consistently climbs higher and faster than everyone else. It finds better solutions, and it does it more efficiently than the pure explorer methods, that's the blue and black lines, and the pure perfectionist in green. And get this balanced approach can lead to some seriously creative, out-of-the-box solutions. In a different task, one involving a maze, both the perfectionist and JEDi discovered something the pure explorer completely missed. Instead of trying to solve the maze, the little ant robot just learned how to jump over the wall. It's a brilliant, unexpected solution that shows you what can happen when you focus your search. So what's the big takeaway from all this? Well, it's pretty clear it's not about being just an explorer or just a perfectionist. It's really all about finding that perfect balance between the two. The really core idea here, the main insight, is that you don't actually need to explore everything. You just need enough diversity to smartly guide your high-quality search. JEDi manages to avoid the tunnel vision of the perfectionist while also dodging the inefficiency of the explorer. It's just a really powerful new way to think about solving these super complex problems, where the world of possible answers is massive and tricky. And that leaves us with a pretty fascinating question to chew on. This whole principle of just enough diversity, of balancing that wide-angle exploration with a zoom lens focus, it's incredibly powerful. So think beyond just robots learning to walk. Where else could this apply? We're talking about things like designing new drugs, discovering new materials, optimizing financial trading strategies, maybe even solving huge logistical problems. In all those areas, where else could this idea of just enough diversity be the key to finding those incredible breakthrough solutions that we've been missing all along?